Welcome back, everyone. We're going to tackle section 7.4 today, graphs of quadratic functions. Something to remember was back in unit 4, section 4.8, we defined a quadratic function as a function of the form f of x equals ax squared plus bx plus c, where a does not equal 0, and that its graph was a problem. So some key features you need to remember from back then was that if the a value, the leading coefficient, was greater than 0, then it opened up. You had the vertex point was at the lowest part of the curve and it looked like a bowl of soup. So you would have your parabola opening up and your vertex point is the lowest point of the curve. If the a value happened to be less than 0, which means it's a negative number, the parabola is going to open down. The vertex point is at the peak of the curve and it kind of looks like a rainbow. So here's our parabola opening down and at the peak is our vertex point. The other key feature of the parabolas is it has an axis of symmetry, which is a vertical line that goes through the x-coordinate of the vertex. So this dashed line, basically what it does, it splits your parabola in half. So it's kind of like a mirror image that you can fold the paper on itself. And it'll always go through the x value of the vertex. Okay, example 1, f of x equals x squared plus k. In this form of the parabola, we're going to cause a vertical shift because the x squared is our parent graph, and then the k is what's causing it to go up and down. So we're going to graph the functions on the same coordinate system. So we have f of x equals x squared, g of x equals x squared plus 1, h of x equals x squared minus 2. So back in your Algebra 1 days, when we wanted to graph, think of the f of x as the representation of the y equals. So I'm going to pick 3 corner points. So I want to know what x resulted in y. So I'm going to use -1, 0, and 1. And the reason I use those 3 values is because if I square a negative, I become positive. So there's positive 1. 0 stayed 0 and 1 stayed 1. So this is our parent, this is what we call our parent graph. So they want us to graph all 3 graphs on the same coordinate grid. So this one is our parent graph. This is the one we're going to start. See here, it's going to be it's the same graph, only has a +1, which means this one is going to cause a shift up from the parent. This one says x squared minus 2, which means it's going to cause a shift down from the parent. You will always use the parent graph as your starting base, and then you will do your shifts from then. So what I'm going to do is I'm going to take a ruler and I'm going to do a coordinate grid here since I'm using graph paper. Label your axes. This is our x, here's our y. I'm going to start with the parent graph. The parent graph is going to be, says the ordered pairs are -1, 1, 0, 0, and 1, 1. This is why I did the T-chart here. So we have -1, positive 1, there's our first point, 0, 0, and then 1. And we just draw a curved graph going through those points. Put arrows on the end since our graph is not stopping, it is continuous. Our second graph, parent graph, says it's a shift up. Well, it shifts up 1 unit because it says +1. So all your ordered points that you just plotted, the 3 points, you're going to bump them up 1 unit. So it's going to go up 1. This one is going to go up 1. We are just rising everything up 1 unit. The y value is what's changing. I'm adding 1 to the y value. So 1 plus 1 is a 2. 0 plus 1 is a 1. 1 plus 1 is a 2 again. So here are 3 points. And again, you draw your curved lines in, and that is your g of x. The last graph we have is the second one, which is a shift down. Well, it's a shifting down 2 units, and it's the parent graph, not the orange graph, the parent graph that started at the origin. So these dots, our y-axis, are going to go down 2 units. So we're going to go down 1, 2, 1, 2, again, 1, 2. And if you notice, the distance from the point on the left to the y-axis and the point on the right to the y-axis is equidistant. Draw your graph in. That is our h of x, and our parent graph was the f of x. Another thing to remember is that the x coordinates did not change for any of our functions. The only thing that's changing is the y value. In this example, example 2, we're going to do f of x equals to parentheses x minus h closed squared. So these are known as your horizontal shifts. Again, we're going to graph the same three functions, all on the same coordinate grid. F of x is equal to x squared. G of x is now equal to the parentheses of x plus 1 closed squared. H of x is equal to parentheses x minus 2 closed squared. So again, this is our parent function here. And again, if we do our t-table, we're going to use negative 1, 0, 1. 1, we plug them in. Negative 1 squared becomes a 1, 0 is a 0, 1's a 1. Now, the difference between a vertical shift and a horizontal shift, these are your horizontal shifts. The change is on the x, so it's whatever's on the inside. So if I were to take the inside parentheses and set it equal to 0, so we have x plus 1 equal to 0, x is equal to negative 1, which means we're shifting to the left. If we do it on this one, it says x minus 2 squared, so I'm going to do x minus 2 and set equal to 0. So x is equal to 2, which means we're going to shift to the right. So now since I know what is going to happen with our graph, we're going to graph our parent function again. Label your axes, x and y. Our first graph started again at negative 1, 1, 0, 0, and 1, 1. So we're going to plot our points. So negative 1, 1, 0, 0, 1, 1. And our graphs, curve your line, put arrows on the end, and label your graph. That is f of x. Our g of x equation says it's going to shift to the left 1 unit. So it means we're not affecting the y values, we're affecting the x values. So each dot is going to move, coordinate point that we've plotted already, to the left 1. So we're going to go to the left 1, to the left 1, to the left 1. And then draw your curve and label that your g of x. The last function says h of x, x minus 2 squared. So it means we're shifting to the right 2 units. So we're going back to our parent function, and each coordinate point is going to go to the right 2 units, not up. So we're going to go 2 to the right, 2 to the right, 2 to the right. And then curve your parabola in and label it your h of x. So the difference between this example and example 1 is that we're affecting, this one affects the x coordinate.